morning. Today we are going to do the last lesson under real numbers. And this is lesson 5.4 in module 5. And so today we are going to compare and order real numbers. Okay, so our learning target, I can use rational approximations to compare and order real numbers, including irrational numbers. The vocabulary that we are going to be using is real numbers, and we have already done this. So, a quick recap, what are real numbers? So, real numbers are made up of your rational and your irrational numbers. And as you can see, irrational numbers I've written over here under the vocabulary, integers and whole numbers, natural numbers. These are all your rational numbers. Irrational numbers would be like pi, all right? The square root of 3, I mean, numbers which are not perfect squares like that. So, square root of 7, etc. So those are irrational numbers, and both rational and irrational numbers together comprise your real numbers. So today we are going to compare and order real numbers. And you can see over here, I've written some numbers over here. These are all real numbers. And we are going to first always remember, whenever we are comparing and ordering numbers like we have done in the past, that you are supposed to always put them in the same format. So I would highly suggest that you put them all in the decimal format, because then it is easy to compare decimals. So make sure that they're all put in the same format before you start comparing and ordering them. So one way to do that is a decimal format, okay, or decimal expansion of each number to compare a set of numbers, okay. And so again, we are going to put them in the same format. So let's look at these numbers that we have over here. We have 18 fifth, we have pi, and we have square root of 11. So we are going to write each number in the decimal notation. So 18 over 5, all right, this is going to give me, when I divide 18 by 5, I am going to get 3 and 6 tenths. This gives me 3 and 6 tenths. Okay, if I look at pi, I know the value of pi is also 3.14 or 3 and 1400, and which is an approximation whenever we are using this. So this is approximately 3 and 1400. So I put the approximate value, all right? And then the square root of 11. And we learned how to do this yesterday, and I will do a quick refresher in a minute, all right? So when we are finding this, we get approximately, I find this one, all right? So it's going to be 3 and 3200. Okay, so now we have all of them in the same format, and then it becomes easy for me to compare and order each of them by using the less than, greater than, equal to signs, etc. Okay, so as I can see, if I'm looking at these three, this is the smallest, this is the next, and this is the largest, right? So I'm just going to write it out like that when I'm comparing these numbers. So I have 3 and 1400 is less than 3 and 3200, which is less than 3 and 6/10 over here. All right. And then all I do is I am going to again replace it back with what I started with. 3 and 1400 was what? This was pi is less than 3 and 3200 is square root of 11, and 3 and 6/10 is this is going to be 18 over 5, or 18 fifth. Okay, so now I can see when I'm looking at that, how I'm comparing it. As you can see, when I convert them into the decimal expansion, it is so much easier to compare them. I can show you this on a number line. Okay, so if I do a number line like this, okay, and I start from 3 and I go to 4 with the 10 parts in the middle, okay, so I have 3 and 0/10, and then I have 3 and 1/10, 3 and 2/10, 3 and 3/10, 3 and 4/10, 3 and 5/10, 3 and 6/10, 3 and 7/10, 3 and 8/10, 3 and 9/10, and we have 4. So you can either write 4 and 0/10, or 3 and 0/10 over here. Okay, and so if I am going to be plotting these numbers over here, I know that 3 and 1400, this one, okay, this is going to be somewhere here, okay, somewhere over here. So if I mark this, this is going to be my pi, all right, and then I have this one, 3 and 3200. Okay, so this is going to be somewhere here. All right, and so this is my square root of 11. And then I have 3 and 6/10, which is here. And this is 18/5. Okay, so I know that on a number line, okay, the more the number is to the right, the greater the number is. And the more it is to the left, the smaller the number is, right? So as you can see, based on this, yes, we have pi, which is the smallest. Square root of 11 is to the right of pi, so that's why it is greater. And then we have 18/5, which is to the utmost right, so that's going to be the greatest. Okay, so once again, on the number line, the more a number is to the right, the greater the number is going to be. All right, so this is one example that I wanted to show you where you put them in the same format. So let's go ahead and try to compare some numbers now to see that which one is greater, which is smaller. All right, so all right. So if I give you square root of 8, and I give you 2 and 2/3, and we have to decide which one is greater, and then we are going to graph the numbers on a number line. So first we are going to compare the numbers. And what we're going to do is in square root of 8, we are going to estimate to the nearest tenth. Okay, so when you're estimating, please remember what we had done earlier, okay, from yesterday. And if I'm looking at square root of 8, when we are estimating that, we know that 2 times 2 is 4 and 3 times 3 is 9, right? So if I have, 4 and I have 9, where is the square root of 8 falling? Is falling between 2 and 3, okay? Because 2 squared is going to give me my 4. 3 squared is going to give me 9, right? So we know that this is going to be between 2 and 3. All right, so when we are doing that, and then we had done yesterday, which is greater, which is more, because look, all right, so this is going to be 4. These are the perfect squares, and this is 9, right? And so if I do square root of this, what do I get? I get 2, which is less than square root of 8, which is less than 3. Okay, and this is what we had done yesterday. And then if you're rounding to the 10th, we were doing the estimation. So I know that if I'm looking at square root of 8, I'm thinking that is going to be closer to the square root of 9, right? So I'm going to take numbers like 2 and 8/10, because if I'm going to round it, and 2 and 9/10, and see if this falls within that category. And so I'm going to do 2 and 8/10 squared should be less than, okay, I have a square root of 8 squared. This should be less than 2 and 9/10 squared. Okay, so if I am solving this, if I simplify this, what is 2 and 8/10 times 2 and 8/10? I'm going to get 7 and 8400 less than square root of 8 squared is going to give me 8, which is less than 2 and 9/10 times 2 and 9/10 gives me 8 and 4100. All right. So this is again, please remember, this is a refresher from yesterday just so that we can see how to put it in the decimal format. Okay. So now if I'm looking at 7 and 8400, okay, and then I am looking at 8 and 4100. Okay. So I can see that square root of 8 is going to be closer to to this number compared to this number. Okay, so therefore we are going to say that this is going to be 2 and 8/10. Okay, so the approximation of that is going to be 2 and 8/10. All right, so that is why we are now going to go ahead and to do the solving. And so we are going to say square root of 8 is going to be approximately 2 and 8/10 based on what I just showed you, because we're rounding to the nearest tenth. And we know that 2 and 2/3, and we've done this before with fractions. 1/3 is 33.3% repeating, and 2/3 is 66.6% repeating, or you just have your repeating sign. So in this case we're going to have this is approximately, all right, or actually it's not an approximation, it's the actual one in this case. So this is equal to 2 and 2/3 is, what did I say, 66.6%, or 6600, or 6/10, which is 6/10 is constantly repeating, right? So this is the value of this one. Okay, now let's look at this. And since 2 and 8/10 is greater than 2 and 6/10 with a repeating sign, okay, so what does that tell us? That we are going to say that I have square root of 8, right, is greater than 2 and 2/3. Okay, just by looking at this. So again, we have changed it to what? We have changed it to a decimal expansion. It makes it so much easier to compare. Now, if we were graphing this on the number line, okay, all right, and we have this. So if I had 2.4, 2.5, 2.6, 2.7, 2.8, 0.9. Okay, so if I have got this written out like this, I know that 2 and 2/3 is going to be here. Okay, this is 2 and 2/3. And then we have, this is approximately 2 and 8/10. All right, so it's like in between 2 and 8/10. And see, look, it's between these two, right? So since it's closer to 2 and 8/10, I am just going to put it over here. Okay, so this is your square root of 8. So these are all decimals, y'all. I don't know if you can see it clearly over there, but just wanted to show you that. So here we go, and here is the graphing, and we can see that square root of 8 is to the right of 2 and 2/3 on the number line, so therefore it is the greater number. All right, so basically again comparing by using the same format. Now let's try another one. And which symbol would I use, less than, greater than, or equal to, in order to compare? So let's go ahead and take some negative numbers this time. Okay, so we're going to take negative numbers this time. And so if I say negative square root of 6, and I say negative pi over 2, all right? So which symbol would it be? This? Would it be this? Would it be this? All right. Would we use to complete this statement to make it true? All right. And so we are going to do an approximation once again. And again, based on yesterday's lesson, I am going to find that negative square root 6 is approximately negative 2 and 4/10. Negative 2 and 4/10. Okay. So we are going to round to the 10th place value for this. Okay. And then I have negative pi over 2. And so that is going to be approximately negative 3 and 1400, because that's the value for pi that we gave over 2. All right. Or if I am dividing that, what do I get? I get negative 1 and 5700. Okay, 1 and 5700. Now, since like these are negative numbers now, so since negative 2 and 4/10 is less than negative 1 and 5700, so we are going to say that negative square root 6 is less than negative pi over 2. Okay, so then this is the correct inequality to use in this case. Now, next we are going to graph this on the number line. Okay, and okay, can we see the whole thing? Yes. All right. So we have negative 2 and 5/10. All right, so we are going to go obviously backwards because these are negative numbers, right? And then we go to, let's just do it this way. Negative 2 and 4/10, negative 2 and 3/10, negative 2 and 2/10, negative 2 and 1/10, negative 2 and 0/10, right? And then we have negative 1 and 9/10, negative 1 and 8/10, negative 1 and 7/10, negative 1 and 6/10. And then let's go one more. And here we have negative 1 and 5/10. Okay, over here. So if I was graphing this, all right, so we have negative square root of 6. Okay, this is going to be somewhere over here. Okay, so this is my negative square root of 6. And then negative pi over 2 is going to be here. Okay, so this is going to be my negative pi over 2. So once again, on a number line, the number which is to the right is going to be the greater number. So therefore, negative pi over 2 is going to be greater than negative square root of 6. So again, putting them in the same format, and that's the decimal format, always makes it so much easier. Okay. Let's do a problem where we have several different numbers, and then we are going to graph them from the greatest to the, we are going to graph them from the least to the greatest. Okay, least to the greatest. All right, and we are going to use, of course, these symbols, these inequalities, or the equal to sign to tell us which is greater or less. All right, so we are going to order square root of 30. Okay, and 6, 5 and 4/5, and 5 and 3600 with a repeating sign over the 600th. All right. So now what we're going to do is we are looking at the first one again. And just like we did in the last lesson, we are going to round this to the nearest 10th place. Not round, sorry. We are going to take it to the nearest 10th place. All right. So we're going to estimate to the nearest 10th over here. So when I do that, I am going to get, I know that 5 times 5 is 25. 6 times 6 is 36. So I know that square root of 30 is falling between 5 and 6. And then by using the lesson, uh, where we are uh, taking decimal values, we can see that this is going to fall right about here. 5 and 5/10 is what I'm going to get over here. Okay, so that is an approximate value. Okay, now then when I look at 6, this is already, this is 6, right? We are writing these as decimals. I can write it as 6, or I can write it like this to the 100th place value, doesn't matter. Okay, and then 5 and 4/5, 4 over 5 is going to be 8/10, that part. So this is going to be 5 and 8/10. And then the last one, we are going to write it as a decimal to the nearest 100th place value. So this is approximately, we know that if it's on the right, we have a 6, this is going to be 5 and 3700. All right, so we're going to round it to the nearest 100th place value. Now, once we have this, we are going to write these numbers from the smallest to the largest. So what's the smallest one over here? Is this, is 5 and 3700. Next, we have 5 and 5/10. Okay, so as we can see, we are writing them in the correct order. Next thing we have is 5 and 8/10, and the last one is 6. Okay, so now that we have placed this in the correct order, we are going to put the original format. So from least to greatest, least to greatest. Okay, what's the first one that we have? We have 5 and 3600 with a repeating sign over the 600. The next number here that we have is going to be a square root of 30. So we are putting the original format back. All right. Next one is 5 and 4/5. And the greatest is 6. All right. So now here are the numbers in the correct order. If I were to graph this on a number line, okay, I am just going to make the number line like this. 5 and 2/10, 5 and 3/10, 5 and 4/10, 5 and 5/10, 5 and 6/10, 5 and 7/10, 5 and 8/10, 5 and 9/10, and 6. Okay, and then I am just going to go ahead and plug in these values over here. And so 5 and 3600 is here. Okay, so this is 5 and 3600 with the 6 repeating. And then I have a square root of 30 is going to be over here. And then I have 5 and 4/5, which is here. And then the last is 6, which is here. So look once again, placed in the correct order on the number line. As you can see, 6 is to the utmost right, and so therefore that is the greatest number. All right, and so graphing them in the correct order from the smallest to the largest. All right, one last problem. Let's say, okay. Let's say on Wednesday there's an 83 and 1/3% chance of rain. 83 and 1/3% chance of rain. Okay, so on Thursday there's a 9/10 chance of rain. 9/10 chance of rain. Okay, and on Friday there's a 6 out of 7 chance of rain. 6 out of 7 chance of rain. So on which day is there the greatest chance of rain? Okay, so we are going to change these to percentages, to decimals in the same format. So if I look at 83 and 1/3, this is going to be approximately 8300. Okay, so 8300. What is 9/10? 9/10 is 90/100. And 6 out of 7, which is 6 divided by 7, I am going to get approximately 8600. Approximately 8600. So now we are going to order the decimals, because we are talking about which day is there the greatest chance over here. So I am going to say, what's the greatest number here? Is this one. Okay, so 90/100 can also be written as 9/10, right? Is greater than 8600, which is greater than 8300, right? And so once I have this set up, all I'm doing now is I am going to substitute the values. What was 9/10? It is 9/10. What was 8600 was 6/7. So we are putting the original formats. And then 8300ths was 83 and 1/3%. Okay, so which one is this? So we said this was Wednesday, this was Thursday, and this was Friday chance of rain, right? So where is the greatest chance of rain now? It's definitely this one here, as we can see. All right, so therefore there's the greatest chance it will rain on Thursday, which is the correct answer. All right, so once again, that is what this lesson is about. I am using rational approximations to compare order real numbers, including irrational numbers. And I am definitely changing them to the same format of decimal expansion because it is easier to compare numbers when they are in the same format like this. And then that would conclude our module 5, which is all on real numbers. Have a great day, everyone.